Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about coordinate geometry of the line. In this question there's loads of information at the start and it could really throw you off. The only piece of information that we need in order to find the coordinate P is the very last piece of information that was given. They told me the ratio of AG to GP is 2:1. That's the only thing we're going to consider in order to answer part A. If they're talking about the ratio of a line, you need to realize that you're subbing into this formula. This formula, if you know the coordinate A and the coordinate P, then this formula allows you to divide a line in a specific ratio. In this case, I'm dividing the line in a ratio of 2:1. And I'm going to call this, that's my A and that's my B. Those are interchangeable, but I'm going to label that as my A and that is my B. Because I've labeled that as my A, this will be my x1, y1. Because I've labeled that as my B, these coordinates will be my x2, y2. Now remember that we would usually use this coordinate and this coordinate in order to find G. In this case, I'm going to have to use the formula slightly differently because I already know the answer, but I need to work out what this coordinate would be. But let's just work off the assumption that we're subbing in, we're just using the formula as usual. We're subbing in, this is my x1, y1, that's my x2, y2, that's my A, and that's my B. As you can see on this line, I've just subbed straight into the formula. If you sub into the formula, the x value would work out as, it works out as 0 plus 2 times x2 over 3. The y value works out as 6 plus 2 times y2 over 3. That's this bit and this bit. That's as far as I can simplify it using this formula. But remember, we already know what the answer should be. We know that if we divide this line in a ratio of 2:1, my answer is the coordinate G. The coordinate G being 2/3, 4/3. So you can see I've already set this up. I know that the x value is going to be 2/3, and using this x value, as far as I could simplify it down, was 2x2/3 plus 2 is equal to 2/3. Clearly here I've got one equation, one unknown, which means I'll be able to find the value of my x2. If I just take it from there, I can ignore the 0, and I can just take 2x2/3 is equal to 2/3. Now I could divide both sides by 2/3 here, but you can clearly see by looking at it that x2 is just equal to 1. So all of a sudden now I know that the x value of P is actually 1. I can do the exact same thing with this formula. Using the ratio formula, as far as I can simplify this one down, is 6 plus 2y2/3. But I know that the y value is going to be 4/3. So I can let the simplified version here equal to the answer. And at this stage, actually if I just take it from here, I could multiply both sides by 3 to just get rid of my fraction. So if I go from there and I just multiply both sides by 3, my fraction is gone. So I could actually just say that 6 plus 2y2 is equal to 4. If I subtract 6 from both sides, I get 2y2, 2y2 is equal to 4 minus 6. In other words, 2y2 is equal to minus 2. And if I divide both sides by 2 on this line, I end up with y2 is equal to minus 1. In other words, the y value must have been a minus 1. So now I know that in fact the y value of P was minus 1. If originally I had subbed in, this is my x1, y1, this is my x2, y2, my final answer would have been 2/3, 4/3. So that's my final answer for this question, is just 1 minus 1. Now the rest of this question is quite straightforward if you know your theory. At the start they mentioned that G is the centroid of the triangle. The centroid of a triangle is the point of intersection of the 3 medians. Okay, and a median, so all triangles have 3 medians. And a median goes through the midpoint of one of the lines and through the opposite vertex. So you need to recognize that the line AP was one of the medians. So it goes through A and then it goes through the midpoint of the opposite line. In other words, the coordinate that we just found, P, is actually the midpoint of the line BC. Now if I know the coordinate C and I know the coordinate P, I can very easily find the coordinate B. Based on my knowledge of the centroid and my knowledge of medians, I know that P is the midpoint of C and B. In other words, the distance from C to P is the same as the distance from P to B. So I can just do a very straightforward translation here and work out what B is. Whatever I did to get from C to P, I have to do the same thing to get from P to B. With my x values, in order to go from 4 to 1, I must have subtracted 3. That means in order to go from P to B, I must subtract 3 from my x value again. 1 minus 3, that means the x value is going to work out as minus 2. Now if we look at our y values, to go from C to P, I must have subtracted minus 3, because 2 minus 3 gives me minus 1. So I need to do the same thing to the y value. So minus 1, I subtract minus 3, and that gives me minus 4. So my final answer there is just that B is the coordinate minus 2, minus 4. Okay, the final part of this question asks me to prove that C is the orthocenter of the triangle. Now, the orthocenter of a triangle is the point of intersection of the 3 altitudes of the triangle. An altitude is a line that goes through one of the vertices and is perpendicular to the opposite side. So the perpendicular bit here is the key for us. If the orthocenter is where a line goes, 3 lines that go through one of the points and perpendicular to the opposite side, the only way that one of the vertices of a triangle could be the orthocenter is if it's a right angle triangle. The only way that C could be the orthocenter of the triangle is if there's a right angle at C. Because in fact, the 2 lines, the line AB and the line BC, the line AC and the line BC are actually altitudes of the triangle. They go through one of the vertices and they're perpendicular to the opposite side. So in this case, all you need to do is prove that the slope of AC and the slope of BC are perpendicular slopes. So try that yourself now, and I'll do it on the board now in a second. So all I need to do here is find the slope of AC, find the slope of BC. As you'll see, I've written out the coordinates A and C, labeled them x1, y1, x2, y2, get the slope of the line, and it works out as minus 1. If I do the same thing for the coordinates B and C, I get the slope of the line and it ends up as 1. Now, whenever you're asked to prove the lines are perpendicular to each other, it's a good idea to just have this line. The formula that you would have been given that specifies the lines are perpendicular to each other, or the slopes are perpendicular, is if you multiply the slopes by each other, they should give you minus 1. The product of perpendicular slopes will always be minus 1. So that's what I'm showing here. That if I multiply the first slope by the second slope, their product is minus 1. That's enough to show that clearly AC is perpendicular to BC. If AC is perpendicular to BC, you can conclude that C is the orthocenter of the triangle. In other words, the line AC and the line BC are in fact altitudes of the triangle. Okay, so I hope this video made sense. If there's anything you're unsure of there, then just send me an email or ask me in class and I'll try and clarify it for you.